This lesson is integration by parts. In this example, we're going to evaluate the integral from 1 to 4 root t natural log t dt. We'll let u equal natural log t, then du is 1 over t dt. dv is everything that's left, which is root t dt. The antiderivative of that is v equals 2/3 t to the 3/2. So go ahead and plug into the formula now for parts. So we have u times v, which is 2/3 t to the 3/2 ln t, minus the integral of 2/3 t to the 3/2 times 1 over t dt. Let's simplify this up a bit. This 2/3 is a constant, it can pass through. The 1 over t and t to the 3/2 can also simplify. So the 2/3 is passed through. The t to the 3/2 times 1 over t has simplified to t to the 1/2, or root t. Remember, we're still evaluating this from 1 to 4, and that's what we're showing here. We're evaluating the whole thing from 1 to 4 before we get done. The antiderivative of t to the 1/2 is going to be 2/3 t to the 3/2, so we need to multiply this with the 2/3 that's already out front, actually the negative 2/3 that's already out front, and we're finally done integrating this. So I've got 2/3 t to the 3/2 natural log t minus 4/9 t to the 3/2, all from 1 to 4. Now let's evaluate that from 1 to 4. So we plug 4 in for all the variables. We've got this expression minus, we plug 1 in for all the variables, we get this expression. Now it's just time to simplify as much as we can. I believe we're just going to pick up a calculator here at some point and generate a value. Actually, we didn't do that. We kept it in exact form. So we've got 16/3 natural log 4 minus 28/9. If you want to know an exact value, or at least that's an exact value, if you want to know an approximate value, you can go ahead and plug that in a calculator and round it off to as many decimal places as are required. In this example, we're going to integrate sine of root x dx. We're going to let r equal root x. dr is 1/2 x to the negative x dx, and this is the same as if we put the multiply both sides by 2. I've got 2 root x dr equals dx. But here's an interesting little scenario. We haven't seen this before. R and root x are the same. So when I have a root x here, that's the same as r. I can do a substitution. So 2r dr equals dx. So this is the same using substitution. Sine root x dx is the same as sine r times 2r dr. So this is a straight substitution at this point. Now we can pull the 2 through. It's a constant, so 2 times the integral r sine r dr. At this point, though, we can't go any further, so we're going to use parts here. We're going to let u equal r, du is dr, and dv is everything that's remaining, which is the sine r dr. The antiderivative of this is v, and the antiderivative of sine r dr is negative cosine r. So we have 2 times this integral, which we're going to use the substitution uv minus the integral v du. So I have negative r cosine r, that's u times v, minus the integral of v du is negative cosine r dr. The negative 1 here can pass through. It's a constant. Give us the plus. The antiderivative of cosine is sine. We need to go ahead and resubstitute our value for r back in, which is root x, before we're done. Here we just distributed the 2 and then just put the root x back in. Don't forget the plus c when you don't have points of integration. That's our learning target for this lesson. I'll see you in class.